All right, so we're going to go over 3 examples, or 2 to 3 examples, I should say, essentially of how to find the slope of a line given 2 shapes that have been reflected over a given space. All right? Now, for the first one, we are going to have a pre-image. Okay? Well, I just want to get this coordinate value. I need my straight edge. There we go. All right, so we're going to have this coordinate value here. These planes. There we go. All right. So the first image or the pre-image is going to start. Let's see. First point is at back 2, down 1, 2, down 2, not 1, 2. Okay. We'll label him A. The next point is going to be over 1, down 5. Over 1, 1, 2, 3, 4, 5. Call that B. And the last point is going to be over 4, down 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay. We can add a couple points up. Okay, and of course, we'll go to our last point. So there you go. Now, my advice is always is to write out the pre-image and image in terms of a data set. It kind of helps you visualize what's going on and helps you identify certain patterns in these kinds of problems. Okay, given the fact you don't know what the reflecting line is, and given the fact that the reflecting line also isn't any known algebraic rule from our notes. Now we do a combination. Okay. Now the image after reflection is going to be, looks like A is at the origin point. Okay. B ends up at 3, negative 1. So it's B prime, that's A prime. And C ends up at, C prime becomes 4, 2. So over 4, 1, 2, 3, 4, up 2. So there's C prime. Okay. Now, the more astute of you should notice that the line is pretty obviously going down to the right. You kind of can tell just by looking at things. Okay, somewhere going through here. That means it's going to have a negative slope. Okay, so I'm going to write down what you know so far. Okay, negative slope on reflecting line. Okay, so what we know. We also know the pre-image and image. Right? So we know that stuff. That's good. So let's go ahead and just write up that in terms of over here. So we have A, B, and C. A is negative 2, negative 2. B is negative 1, 5, negative 5. And C is negative 4, negative 6. The image then becomes for A prime, B prime, and C prime. A becomes 0, 0. B becomes 3, negative 1. And C becomes 1, 2, 3, 4, up to 4, 2. Okay? So, good stuff. All right? Now, at this point, you've gotten all the information out of this that you can just give up to your images, which is what you'll be given on typically one of these questions. The next thing you want to do is, okay, well, let's determine essentially the points between, let's connect all the points together. So I'll take out the color here, and I'm going to connect A to A prime, C to C prime, and B to B prime. Okay? Now, the next thing we have to determine is the midpoint for each one of these lines. There are 2 ways you can do this. You can either identify it just by looking at it, which is typically what you'll end up doing on most of the Delta Math problems that these came from, but hopefully not, or you actually use the midpoint theorem. Does anybody remember what the midpoint theorem was?
It's to like count the horizontal and vertical spaces between the 2 points, and then it gives you a number, and then you split the number, and that's how far
Close.
It's something to do with slope. Yeah.
Kind of. So the midpoint theorem, okay, as you guys know, now it does involve slope in some way, or at least involves being able to identify it. Because since this has a consistent slope between the 2 points, okay, we can actually calculate. Now, it's related to this because the function does care about the same thing the midpoint, the slope cares about, which is the change in x and y. The difference is we're not putting them both in a fraction, we're instead putting both of them under above 2. So midpoint is actually x1 plus x2 over 2 and y1 plus y2 over 2. Again, for just comparison reasons, okay, so just for comparison, the equation for slope is m equals the change in x over the change in y. Whoops, I messed that up. Y over x. The change in y over the change in x. Okay, it's going just a little bit more energy out of it, which essentially is y2 minus y1 over x2 minus x1. Which, as you can see, that's where the relationship comes in. In this case, however, we're caring about the positive change, or the overall change, versus the negative change. Now, yes, delta is still used to denote change of something, but the problem is that it gets a little ambiguous when we're talking about, okay, is that a positive change, or a negative change, or a difference change, or an addition change? It depends upon the formula, and most times, or 9 times 10, they will tell you outright what type of change they're looking for. But that's why we don't use delta here, and why we use delta here. Because typically it's for a negative change. Okay? That's just a math language for you. So if you see delta, assume subtraction. Basically, we want to get it. Unless they state otherwise. Usually they'll have a subscript to it saying, like, delta as a positive change, or delta a plus b, or something of that nature. It'll look something like this, basically. It'll look basically like a plus b, kind of in a subscript down there. But again, don't consider yourself with that at this level. I want you guys to focus more on the fact that these are the two, this is the change, and this is just essentially asking for the overall midpoint. Okay? Now, with all that said, let's figure that out. Now, we could calculate this, so always do it for one of these. We'll do it between a and a prime. Seems pretty reasonable since it's the shortest distance. So we basically take the points we know, which, oh, hey, look, they're right there. Wonderful. So we'll take that information, okay? I'll go down here with it. So we know that the midpoint of A and A prime, okay, so that's just a subscript, would be then 0 plus negative 2 over 2, oops, that should not be there, comma, and then 0 plus negative 2 over 2, comma. Naturally, that gives me negative 2 over 2 for both, which gives me what? Negative 1, which is right there. And that's how you find the midpoint. You repeat this process for every single one of these going down. Okay? So for the midpoint of C and C prime, before, you're going to have the x's would be negative 4 plus 4 over 0, comma, and you're going to have negative 6 plus 2 over 0. That's 0. How am I doing? 2. Very hard. Clearly not eating enough at lunch. Okay? And that gives me 4 plus 4, that gives me 0, so that's going to give me essentially 0 over 2. Negative 6 plus 2 is going to give me negative 4 over 2, which gives me 0 and negative 2. It's right there. Look at that, they're lining up. Okay? Now, one thing you can also make a little shortcut here on is you can obviously notice that the distance between this point to this point is over 1 and down 1. It's a negative 1 slope. Very good. So that means I can just literally line up my straight edge and just go, there you go. And cut them all in half. Now that we've done that, we can then say that this part is going to go to this part, this part is going to go to this part, and this part is going to go to this part. Should I use those take lines in the opposite directions? The lines are short, but whatever. Okay? Happens. And of course, we have a right angle on each one of these, and they're perpendicular bisectors. Everything checks out. We now have enough information to know and figure out what the line of the reflecting line is
with this information. As we already determined, the slope is obviously equal to negative 1. So our first part, which means we need to break out the old slope intercept equation, which is
Y equals
very good. And with this guy would be y equals negative 1x, and your b is your y-intercept. Forget about him. That y-intercept is wherever it crosses the the y-axis, which is right there. And that is negative 2. So your simplified answer is negative x minus 2. And that's what we were looking for. So using just shapes, you can find the slope of any line or determine what the line of reflection is, so long as you have the pre-image and image in some capacity, be it just the shapes or the coordinate values or whatever. But if you don't have one of those two things, then you're kind of stuck. Okay?